Hi, I'm Vaishnavi Dasari. I'm an ML engineer.
Hello everyone, I'm Snehita Burga. I'm a full stack developer.
Hi everyone, I'm Ashrita Bhimsetti. I'm front-end developer.
Hello everyone, I'm Abhisaynath Reddy Aripalli. I'm a backend developer.
Hi everyone, myself Shoaib Khan. I'm backend developer.
Hi guys, myself Dhanush and I'm a machine learning engineer.
Hello everyone, I'm Neil Kamal Rana and I'll be the full stack developer for this project.
Thank you guys. Let me share my screen. So yeah,
Right, so our project is Cybersentinel and we are Team Tech Titans. Can you go to the next slide, Snehita? So we have created our agendas and we have classified it into 6 different denominations. One is team and planning, other one is user and product definition, third one is technology and implementation, fourth one is project documentation and management, fifth one is tracking and evaluation, and the sixth one and final one is demonstrations and resources. We have subdivided each of them into 3 to 4 categories. Go to the next slide. So, like you can see, we are the team members. I myself being Vaishnavi Dasari. I'm an ML engineer, Snehita being a full stack developer, Ashrita being a front end developer, Abhi Sainath being a back end developer, Shoaib being a back end developer, Dhanush being a machine learning engineer, and Neil Kamal being a full stack developer. The improvements we have made in this sprint were addition to our team page, fixing the wiki page, and fixing up the team agreement. Like the project description, I would like to add upon, like we know, as I've started, Cyber Sentinel being the project name, team is Tech Titans. What we are basically doing here is Cyber Sentinel being an AI powered cybersecurity assistant designed to proactively safeguard users against digital threats. By integrating advanced machine learning algorithms, it offers real time monitoring, threat detection, and personalized security guidance to enhance users' online safety. We have added a user dashboard that includes security overview, recent alerts, system health check, threat detection, personalized security guidance, as well as automated security tasks. We even have benefits and outcomes for this. That is, we have real time detection and prevention of cyber threats, adaptive learning capabilities to counter evolving attack techniques, seamless integration of automation and analytics for efficient proactive cybersecurity, and it is very user friendly. Below is our GitHub link. In our team agreement, we have actually done added topics of like communication, professionalism, meeting cadence, and team members. The most major part we had problems were about communication, which we improved drastically over time. We showed our best performance, best behavior, and we were very professional during this. And we had, during meetings, we were able to put weekly meetings. We even had mid-week asynchronous updates and additional meeting schedules if needed for urgent discussions. I hand over to my friend for further discussion.
Hey, hi guys. Good evening. So I'm here to explain some of the personas which was taken for this project. So the first persona I'm going to say about is Alex, who works at a mid-sized tech company and is well versed in various technologies and spends considerable time online both professionally and personally. So aware of that, some cybersecurity threats must seek advanced tools to enhance personal security. So while coming to Alex, his personal goals are protect personal and professional data from phishing and other cyber threats. And the second one is stay informed about the latest cybersecurity practices. And the third one is utilize AI-driven solutions for proactive threat detection. So the challenges which he faced while doing these things is balancing convenience with robust security measures and identifying trustworthy cybersecurity tools amidst numerous options. So the next persona I'm going to talk about is manages. So here is a Maria Thompson. He manages a team. She manages a team remotely for a marketing firm. So juggles professional responsibilities with parenting two teenagers. So uses multiple devices for work and personal tasks. And her goal is to ensure the security of sensitive work-related information. And second one is protect family members from cyber attacks, especially her children, and from online threats. So she has to maintain a secure digital environment across all devices. So the challenges which she faced in this project is limited time to manage and monitor cybersecurity measures. And the second one is keeping up with evolving cyber threats and ensuring family compliance with best practices. So the third persona which we are talking about is David Kim. So he runs an online storefront in addition to the physical store, handles customer data, including payment information, has basic knowledge of cybersecurity but lacks specialized expertise because he's from business background. So his goal is to protect customer data to maintain trust and comply with regulations. Second one is prevent financial losses due to cyber attacks. And third one is implement cost-effective security solutions without extensive technical knowledge. And the challenges which he faced is limited budget for cybersecurity investments. And second one is difficulty in accessing which security measures are necessary and effective. So next thing I'm going to talk about is minimum viable product, MVP. So phishing email detection is the first thing, classifies emails as safe or phishing using NLP models trained on datasets. The second thing which we use is fraudulent transaction detection. So that identifies suspicious transactions using anomaly detection techniques. And the third one which we used is URL classification. Determines if a website link is malicious or safe based on its lexical features. And the fourth one which we used is user dashboard, displays alerts and risk analysis based on detect threats. And the technologies which we use in this project is our development stack comprises modern, scalable, and effective technologies. The front end is built using React.js to ensure a simple and interactive user interface. The backend is powered by Flask, a lightweight Python-based framework that enables API development. Um, PostgreSQL serves as our database, allowing us to store detected threat data effectively. Lastly, we leverage AWS for cloud deployment and scalability, ensuring a reliable and secure infrastructure to handle cybersecurity operations. So the next thing is going to continued by our friend Asrita.
Hi everyone. Coming to our algorithms that are used in our project are, we are using three algorithms in our project. One is BERT algorithm, that is bidirectional encoder representations from transformers. This is basically used to detect the shipping emails from the attackers. This is basically used because it is a pre-trained deep learning model for text classification. This captures a contextual meaning of words, improving phishing email detection. We are using this BERT algorithm because it gives high accuracy of shipping email datasets and gives a fine tune to those emails. And for coming to fraudulent transaction detection, we are using autoencoder with isolation forest. We are using this algorithm because it reduces the dimensionality and extracts the essential transaction features. And forest detects anomalies based on the learned representations. It is efficient for unsupervised supervised learning, detecting fraud without requiring labeled data. Coming to the URL classification, we are using CNN plus LSTM algorithm. CNN extracts spatial features from URL structure, and LSTM captures sequential patterns, improving detection of phishing URLs. This is an hybrid deep learning model for better performance over traditional classifiers. So these algorithms are going to be used in our system. Coming to architecture design, When user we are using React.js for our user interface. When user sends the request, it goes to the Flask API, and results will be given to the user interface. When requests are sent to Flask API, we will divide those by threat intelligence, fetching threat, or using the PyTorch machine learning models. Then when the threats are defined, then we are using PostgreSQL database to store these thread data, and this thread data will be again processed to the Flask API, and it will like notify to the user as the what threat has been came to their system or phone. That's it for the architecture diagram. Next slide, please. Coming to the context diagram, here when the user sends the request, it can be like email, URL, or transactions within the system. Then the user submits email, URLs, or transaction data to a Cybersentinel system, which processes from a shipping and fraud detection. We are using AI models like we are using AI models to check the fraud data and shipping emails. And this can be sent to the Cybersentinel system to notify the user. Then the results are stored in the PostgreSQL, which are using as the database. Then the system then sends back the verdict to the notify the user of any detected threats, ensuring transparency and proactive security measures. Next slide, please. Coming to the ER diagram, entity relationship diagram represents the database structure of our system. At the core, we have users who interact with different entities such as transaction, email, and URL. Each user can initiate transactions, receive emails, and check URLs, all of which are linked to risk classifications. The PostgreSQL database maintains relationships between these entities, enabling effective data storage and retrieval to enhance threat detection capabilities. Next slide, please. My friend will continue.
Yeah, coming to the sequence diagram, this diagram describes the step-by-step interaction between system components. The user initiates an action by entering an email, URL, or transaction details. The frontend sends this data to the backend, which processes it through AI engine. The AI engine classifies potential threats and stores the results in the database. The backend then retrieves the classification and sends the final risk analysis result back to the user, ensuring a smooth and responsive security assessment process. Now, coming to the state diagram, the state diagram outlines the different states within the system as it processes user inputs. Initially, the system is idle until a user submits an email, URL, or transaction for analysis. The system scans and processes the input, categorizing it based on the detected threat level. If further verification is needed, the system determines whether the input is suspicious, malicious, or safe. If a threat is identified, the system alerts the user while logging the incident for future reference. Coming to the class diagram, the class diagram defines the object-oriented structure of a system. Key entities include users, transactions, emails, and URLs, each encapsulating relevant attributes and methods. The AI engine plays a central role by analyzing emails, transactions, and URLs for threats. By organizing the system into structured classes, we ensure modularity, scalability, and efficient data processing for cybersecurity detection. Coming to the product backlog user stories, our product backlog outlines key user stories, prioritizing essential features for our cybersecurity system. In Sprint 1, we focus on user facing functionalities such as phishing email history dashboard, email filtering based on risk levels, and threat statistics for admins. We also include user management, allowing role based access control, and an initial phishing email detection feature. Each story is structured with clear acceptance criteria, ensuring the system meets user expectations efficiently. Coming to the product backlog user stories, and in Sprint 2 and Sprint 3, we extend our system's capabilities with advanced features. Fraudulent transaction detects helps users identify suspicious financial activity. URL classification ensures phishing websites which are flagged, while sender reputation scoring help users assess email legitimacy. Real time alerts notify users about detected threats, and a feedback system allows users to report false positives, improving system accuracy over time. These enhancements ensure a comprehensive and user driven security platform. Now, I'm handing it over to Neil.
Thank you, Snehita. Coming on to the technical stories, during the sprint one planning, we actually planned on to some technical stories, and during the sprint one, we tried to work on everything, completing most of it. And our most important technical story was the user dashboard. We were able to develop a very comprehensive user dashboard. And apart from this dashboard, the other technical stories were to have a very good user role management systems. And the third important technical story was implementing an open authorization authentication for secured user. And the other technical story was to set up the AWS for all the cloud requirements. And mainly in the first sprint, we were focusing on these four technical stories. And in the upcoming sprint, we have already planned our next technical stories, which will be focusing on the advanced AI model training, and will be using the CNN and LSTS model for the training and the other purposes. Coming on to the next slide, please. Coming on to the sprint one backlog. We prioritized the essential user stories to establish the core functionalities and to be in line with the with the project MVP that we have decided. And the key features includes the email dashboard and some risk risk emailing filter. And the other thing was to ensure the security and control of the system. Next slide, please. Yeah, coming on to the sprint one backlogs. On the technical side, we were focusing on the back-end tasks, and also we focused on implementing some other user role management like the open authorization and the cloud deployment. Now I would like to hand over it to my teammates Shoaib for the next slides.
Thank you, Neil. Hello, everyone. So here are the test cases of our project, like Sprint 1 for Sprint 1. So here we in the test cases to validate our Sprint 1 implementation. So we conducted comprehensive test cases. We verified that the phishing email dashboard displayed email list correctly, and then we have figured out like threat statistic match database records. And then while most test cases passed, so we identified an issue with role-based access control, which did not function as expected. So unrequired, we figured it out like we need the further debugging. And the next slide. Mm. So here, you can see like user 1, 2, 3. So in these test cases, as a user, dashboard. So our technical test cases focused on backend functionality, the threat statistics dashboard, and the user role management system performed as expected. So, but open authentication faced issues, preventing users from logging in security. Additionally, there's this Amazon Web Services (AWS) deployment was only partially successful. Next slide, please. So the sprint one, the stories which are completed are like, despite challenges, we successfully completed majority, like sprint one stories total like 37 stories we are completed. The sprint one stories which are not completed was like two stories remain incomplete in sprint one. So total 13 story points. The user management feature required further refinements, role based access control. Next slide, please. Time velocity. Yes, this is the time velocity. So that here you can see like total story points completed was 37. So in time velocity, our team velocity for sprint one was 37 completed story points. This metric helps us gauge our capacity for further sprints by tracking the amount of work completed. Next slide, please. So here is the burn down chart. This burn down chart visualizes our progress throughout sprint one. So the green line here in this chart, the green line represents the ideal burn down trajectory, while the red line shows our actual progress. We steadily reduced remaining story points over the sprint, with some fluctuations due to challenges encountered. Next slide, please. So here's the completed committed ratio. Our completed to committed ratio for sprint one was 74%, with 37 out of 50 story points completed. So while we made significant progress, this ratio highlights room for improvement in estimation and execution. Next slide, please. So this my friend Abhi will continue from here.
Thank you, Shoaib. Hello, everyone. Uh, the sprint retrospective. In our retrospective, we identified key successes and areas for improvement. Strong team collaboration, successful AWS deployment, and clear sprint goals were among the highlights. However, OAuth authentication and mid-sprint reviews were areas that needs to be improved and which needs to be focused. Our action items for the next sprint includes adding mid-sprint check, and we need to have a better communication to address these gaps. Next slide, please. Sprint 2 plan. For Sprint 2, we are carrying over unfinished user management and OAuth authentication tasks while introducing new features. Key additions include phishing email detection, fraudulent transaction detection, and URL classification. These features enhance system stability to identify and mitigate cybersecurity threats, making it more robust and efficient. Next slide. Uh, in addition to security features, Sprint 2 will focus on AI model training. We will integrate a BERT model for phishing email detection and implement an autoencoder with isolation forest for fraud detection. And we'll deploy a CNN LSTM model for phishing URL classification, as mentioned by Ashrita. These advanced AI models will significantly improve our threat detection accuracy, strengthening our platform's capabilities. And next slide. So these are the screenshots. These are the previews of a Cyber Sentinel dashboard. It provides an overview of email security threats. The interface displays phishing risk summaries, detected malicious URLs, and blocked fraud attempts, as you can see. Users can analyze security trends and take actions based on systems classifications. This dashboard serves as central hub for monitoring potential threats in real time. Next screenshot. Yeah. Uh, let's take a closer look at the email security analysis section, which shows how users can filter emails by risk level and status. The system categorizes emails into phishing, suspicious, and safe, allowing users to review details and take actions accordingly. This functionality improves user awareness and provides transparency into email-based threats. Next slide. So this is our Git page, as you can see, wiki page, GitHub wiki page link. And next slide. So the application demo will be given by Snehita.
Yes. And coming to the application demo, let me show you the. Oh. So this is the email security dashboard, and you can see here Alex Johnson. He's the first persona, and if we switch the role to viewer, we cannot see the add email analysis thing. We cannot add anything, and this is the admin role. We can change an email for analysis. So this is the email security analysis report, and we have two phishing which is marked in red, and its status is flagged, and another one is blocked. The detection indicators are homograph attack, urgent action, and suspicious sender. And what is flagged is spoof domain, urgent action requested, suspicious link. And these are suspicious, and the detection indicators are external sharing and attachment request. And this is also a suspicious email. And we have two safe emails here. And this is how email is. And let me show you the. So here we have email risk summary, phishing 2, suspicious 2, and safe 2. And malicious URLs detected 2 emails. And fraud attempts are, we have 2 blocked emails for this. And weekly summary is 28 incidents total. Let me show you how to add email for analysis. So here I have some. The subject line is exclusive offer, 90% off, limited time. As we get like that mails. So yeah, here we need to click this analyze email. And let's see what's the risk level of this. So here, this is phishing email because the suspicious URL patterns or redirect links and urgent language demanding immediate action. So this is the thing, and we need to add to dashboard. So it will be here. So this is flagged because this is a phishing email, and we can see here the phishing reports 3. So yeah, again we need to add
Yeah.
so I'm stopping this. Thank you guys.
Okay. Thank you.